This video is going to cover how to solve a Lagrangian problem, which we use to solve we use the Lagrange multiplier technique to solve a constrained optimization problem, in this case for the consumer utility maximization problem. And we'll cover this, some of this setup in class. So this is the basic form of the Lagrange multiplier. You take the utility function and then add in with the Lagrangian lambda, and then the constraint. You're adding the constraint here. And then specifically in this case, we're going to have a version of the Cobb-Douglas utility function, x to the 1/2, y to the 1/2. And then we're going to have specific prices for the prices of the two goods. Px is going to be 3, py is going to be 5, and then the income is going to be 60. So the first thing we're going to do is rewrite the Lagrangian here with our specific function in here. No, 60, not 30. Okay, so there we got they have the specific function drawn, written in here. And what you do is the Lagrangian function is a function of 3 variables, x, y, and lambda. And you take the partial derivatives and set them equal to 0. So the partial of the Lagrangian with respect to x is this. Here's the partial with respect to y. And then the partial derivative with respect to the Lagrangian is just going to give us the constraint, the budget equation back. Okay, so what we have here are 3 equations and 3 unknowns. And at this point now, it's just algebra to solve. And you're welcome to do algebra however you want, whatever works for you, just as long as you make valid algebraic steps along the way here. What I like to do is some people are very comfortable just dividing these two first order conditions. It really doesn't matter what you want to do. What I'm going to do here is just let's just solve for lambda. And so you'd have, from this equation, solving for lambda, we have you just move the 3 lambda over, divide by 3, and we get this expression here. Now we can come in and substitute for lambda down here in this equation. Trouble with these exponents here. And let's see. Now, when you get to this step here with the Cobb-Douglas, one thing, this looks like really messy, but then it's going to end up being pretty nice, because what you can do is multiply this equation through by x to the 1/2, y to the 1/2, and what that'll do is clear these nasty exponents here. So you get 5/6. And then that'll allow us to get that x is equal to 5/3 y. Yeah, multiply it, just run it. Now what we can do is well, we've solved for lambda. Okay, got that y, x in terms of y, and then what we have to do is substitute back in here into the budget constraint. And then what we'll get here is that those 3's cancel. You have 60 is equal to 10y. Y is going to be equal to 6. And then, so you have a numerical answer here, and then you have to come over and get the numerical answer for y. For x, x is going to be 5/3 of 5/3 times 6, and that's going to be 10. And so that would be our, in this case, when you have a specific function and actual numbers for the prices and income, you can get an explicit numerical solution for the problem. And this is what we have here. So if you've got specific numbers like this, you get a specific solution. When we give you fewer things, you're going to get less of a solution.